Alright, so we want to find the probability of winning this jackpot. Well, so we're only going to buy one ticket. One ticket is purchased. So the probability of winning is 1 out of the total number of possible matches, which is going to be a lot. So in order to win the lottery, I have to my 5 numbers that I select from 1 through 43, it has to match the 5 numbers that are from the jackpot. And so first I'm going to figure out the number of combinations of choosing 5 numbers out of 43. So I'll do that in a moment. But not only do my 5 numbers out of the 43 have to match, but I also have to have the matching gold ball, and that's just 1 out of 33. If I choose one number out of 33, there's gonna be 33 options. So we could calculate the number of combinations where I choose 1 from 33, but this is going to end up equaling 33. All right, so I need to calculate these two combinations. So we have 43 factorial, and then I subtract 43 and 5. That would be 38 factorial times 5 factorial. And then the 38 factorial on the bottom will cancel out with 38 factorial up top. I'll go ahead and write it out though. So that'll be 38 factorial. I rewrote 43 factorial as 43 times 42 all the way down to 38 factorial. And we have 5 factorial on the bottom. 5 factorial would be equal to 120. So we could, so 5 factorial, that's equal to 120. So we could just write 120. Or we could write 5 times 4 times 3 times 2 times 1, right? It doesn't matter. If we know that 5 factorial is 120, it might be easier just to put the 120 there. And so the 38 factorials, those 38 factorials cancel out. And now we have a choice. We could just multiply the remaining numbers on the top and the bottom and divide after that. That's fine. Or we could reduce everything. Like 5 times 4 is 20, times the 2 would be 40. So the 5, 4, and 2, those numbers multiply to 40, which would cancel out with the 40 there. And the 3 I could cancel with the 39, turning it into a 13. And so I'm left with 43 times 42 times 41 times 13, which I'm going to do on my calculator that I have. 43 times 42 times 41 times 13. With the help of my calculator, I got 96,2598. Right, so there's 962,598 ways of choosing 5 balls out of 43, 5 numbers out of 43. On the next one, it's going to be 33 factorial, and then 33 minus 1 is 32 factorial times 1 factorial. So we have 33 times 32 factorial over 32 factorial, and 1 factorial is just 1. The 32 factorials cancel out, and we're left with 33. Anytime you're just choosing 1, then the answer will just be the number that you're choosing from, right? If there's 33 numbers and I'm choosing 1 at a time, there'd be 33 groups that could be made. All right, so the total number of ways of playing this game would be 962,598 times 33. And I'm only going to buy one ticket, so I only have one chance of winning out of all those. Right, so the probability of winning this jackpot is 1 over, and now I need to multiply these two numbers. And with my calculator, I see that it's 317,656 7, 3, 4. So the probability of winning this jackpot is extremely unlikely. 1 over that big number, 31 million and change. All right. Let's see. A box contains 13 transistors, 3 of which are bad, 3 of which are defective. So 3 are defective, and so 10 must be okay. 10 must work. If 3 are selected at random, find their probabilities. So part A wants me to figure out, if I were to select 3 of these at random, what's the probability that they're all defective? Well, so if I randomly select a transistor, the probability that's defective is 3 over 13, right? There's 3 that are bad out of 13. Now, once I take that transistor and I put it to the side, that means there's going to be 2 defective left out of a total of 12. So the probability of selecting a defective transistor is 3 out of 13. And then once I put that to the side, I now have 2 defective left out of a total of 12. So the probability of selecting a defective one on the second trial is 2 over 12. And then once I put that aside, there's 1 defective left out of a total of 11. And so now we just simplify this. So we have a choice. We could just multiply across, 3 times 2 times 1, and then 13 times 12 times 11 is 17, 16. And now I would have to reduce this, which we could do. It's often easier though if we reduce before multiplying. Notice 3 times 2 is 6. So if I cancel out the 3 and 2, the 6 would go into 12 twice. So that would leave me with 1 times 1 times 1 on the top, and then 13 times 2 is 26, and 26 times 11 is 286. That's easier, in my opinion, than trying to reduce this point. Notice now if we divide 6 by 6 and 17, 16 divided by 6 should be the 286. So here we have the probability of getting 3 defective in a row. Part B, what's the probability that none are defective? If I randomly select 3 and none of them are defective, well, 10 of them are good, so the probability of getting a good one is 10 out of 13. Once I put that to the side, that'll leave 9 good out of 12. And then once I put that aside, there's 8 good out of 11. And once again, we can either reduce or multiply across. I find it easier to reduce in this stage. That way I don't have big numbers to try to reduce. And so let's see, 4 goes into 8 twice, and 4 will go into 12 3 times. And then 3 goes into 3 once, and 3 goes into 9 3 times. And I don't see anything else I can reduce. On the bottom I have 13 and 11, and I can't reduce those with the numbers on the top. So 13 times 11 is 143, and then 10 times 3 is 30 times 2, so the top number would be 60.